Our last two sections of material in Unit 2 are coordinate systems. So we're going to look at the coordinate system, the Cartesian coordinate system specifically. And what we're going to start with today is graphing lines. So every 2 points lie on exactly one line. It's actually really important to know that because what it means is that when you're graphing a line, you really only have to draw 2 points on there. So somewhere along the way, I know somebody probably drilled it into you to do like 3. I don't know why that's the default that people usually go with, but it's not necessary. 2 is enough because between every 2 points, there's exactly and only one line. So we're going to be plotting our lines in this section by using points. I recognize that there are other ways to graph lines, okay? But we're going to start here for this lesson. So we have our line on number 1 of y equals negative 2x. And on each one of these, what I expect to see is I expect to see you plot points. And in order to plot points, you're going to have to figure out what those points are. So you're going to draw some kind of a, you don't have to do it in this order, but you're going to draw some kind of a analysis, if you will, of what an x value gives you, what a y value gives you when you choose an x. I like to set it up in a table. Okay? So if x is equal to, and you get to pick me an x value. 3. Okay, so if x is equal to 3 and you put it into this equation, what will y equal? Negative 6. Somebody pick me a different value. 0. 4 would be fine. You can pick 4. If x is equal to 0, what's y? 0. So you're going to plot these 2 points, or whatever 2 points you got, on your graph. So I have 3, negative 6, which would be down here. And I have 0, 0, which would be right here. And then I'm going to connect them with a line. Sorry, as I draw my lines, I have to shift them so that they'll actually get my points right. That's it. Okay? Choose any 2 x values, get corresponding y values, plot them on the graph, and connect them. So let's try it again over here. X value, y value. Pick an x for me. 4. So if x is 4, what's y? Negative 10. Another x value.
1.
Okay, Zion's really into picking x values for me today. 2. All right, you got to let somebody else pick next time. 2. If x is 2, what's y? Negative 4. Good. Okay, so whatever 2 points you picked, they don't have to be mine. You're going to plot them. So 4, negative 10 is almost off my graph, but it's not quite. And then 2, negative 4 would be right here. And then we're going to connect them. That's pretty close anyway. We'll call good. Okay, so far so good. It will be really helpful when you're graphing your lines. I have this line tool, and it's not the best of what it's doing necessarily either. It'll be really helpful when you do this if you have some sort of straight edge. So use your phone, use your ID card, use something to make an edging on that, and it'll be really helpful. Yes?
Do you care if we use the graphing calculator to plug in?
Yeah, you can use your graphing calculator because there's no work that I'm asking you to show for these.
Okay.
For these.
I didn't know if you wanted us to show the work or not.
Yeah, these points right up here that you're creating, there's nothing that you have to show the work for. For the most part, you can do it in your head. If you're choosing something or if the graph gets more complicated and you're using your calculator to find it, that's fine. It doesn't hurt anything.
But you want the graph to make sure that we write the X, Y graph on?
You have to write down 2 points for me. So if you were to put them and actually mark them on the graph, that would be okay as well. Like if you figured them out and you wrote down 2, negative 4 here, like you actually wrote them, and you wrote down 4, negative 10 here, that would be another way to do it. You wouldn't necessarily have to do like this T-chart thing that I'm doing. But somehow it needs to be actually listed what those points are. I don't want to have to look at your graph and guess.
So we get to choose the x points?
Yes, you can pick any x points you want. To be very honest, I like picking x equals 0. Zion does not, obviously. But you can pick whatever you'd like. We're going to do a couple more. Number 3, somebody else give me a value for x. Make it nice. There's some good options. 0 is a good one on this one. Do not pick 2.
Why not?
I'm going to tell you why. 0 is good. What do you get for y if x is 0? 1. So let's pause for a second and find out why we don't want to pick 2. What's going to happen if we pick 2? You got a fraction. 4/3 times 2, right? That's what it said. That's not very friendly. There's got to be a better number to pick than 2. Negative 2 is not any better. Nice try. 3 would be a good one. Thank you, Walker. 3 is much better. Why is 3 better? It's already in the denominator, which means that it'll cancel, right? So this might be one that you might not actually be able to look at your head, look and see it in your head, and that's fine. But if we're looking at this one, the reason that 3 is nice is because the 3 cancels with the 3 in the denominator, and 2 wouldn't, nor would negative 2. I know, it's a shocker. So 3 is good. If you really want to pick 2, you can, but I would not advise it. So what do we get if we pick 3? 5. So we're going to plot 0, 1. And 3, 5. And then we're going to connect our dots. Good? Okay. What is it about number 4 that is different than the ones we've already done, the 3 we've already done? Okay, so let me combine a couple of the things that you guys just said. The right-hand side is just a number, right? Whereas on all of the other ones, we had it in slope-intercept form, which is what you were saying. So you have a couple options. You don't have to put it in slope-intercept form. It's not required. If you want to, you certainly can. Like you could solve this for y equals and go from there. But you don't have to. You could actually take it the way that it is, and you don't even have to pick x values. You could pick y values. Because it's not solved for x. It's not solved for x or for y. So I actually think it's really nice on this one to pick a y value of 0. If y is 0, what's x? 2. That's nice, right? Sure. I don't know that I necessarily want to pick x as 0 because I'll get a fraction if I do. But you could try if you wish. It's not a horrible fraction. So if you picked x as 0, you would have 4y equals to 2. What would y equal? Huh? Not 0. 0.5. So I would have to divide by 4, right? 2 over 4 is 1/2 or 0.5. So if you ended up doing that, you would get this. If you'd prefer, you could simply go back. You don't have to do that one. I'll erase it just because some of you are looking at me like, why would I do that? You can pick another y value. It's a little bit nicer to pick y values here because y is the value that's being multiplied by the constant 4, right? So maybe you decide, okay, well, y is 0 works nice. How about y is 1? What's it going to be if y is equal to 1? Yeah. So this is 4, right? And if I put negative 2 in here, I would get the 2 that I'm supposed to be getting, the answer that's on the right. Okay, so there's nothing special about picking x's or y's. It was nice for us to pick x's on the first couple of ones, first 3 even, because it was solved for y. This one's just not solved for y, so it's not as friendly to pick values for x. So 2, 0 would be here, and negative 2, 1 would be here. Okay, and we're going to connect them with a line. Sorry, can't grab my line. There we go. Okay, we're about to see something on number 5 and number 6 that we've seen before. Do you remember seeing these before? X equals a number and y equals a number. We saw them back at the end of Unit 1. These, when there's just x or y equals just a number, always create horizontal or vertical lines. Okay, so straight up and down or straight right and left. And if it helps you to remember what you can actually remember, one of the things that I think I've done it in this class. Did I talk about Hoivux? Does that sound familiar? That's a no? Okay. So Hoivux is an acronym that can help you to remember if you want to use that. H stands for horizontal, V stands for vertical. Okay. So it tells you which line is which. So the horizontal is the y equals graphs, and vertical is x equals graphs. The O and the U in between tell you what the slope is. So this O is not really O, it's 0. And this U is not really U, it's undefined. So that's one way to remember. Another way to remember is how these lines are created. For example, if x is equal to 2, this right here has x equal to 2, and you need to plot points that are always a distance 2 away from the x or from the y-axis. It's got to be a distance of 2 away. So you can think about plotting points like this. They would stack up like that. Another option is that you can create your bar x and y, and you can pick. If x is 2, y is, well, anything, 0. If x is 2, y is anything else you want. Y is 5. And then you've got a couple of points to plot, if it helps to think about it that way. So this is 2, 0. This one's 2, 5. Any of those ways will lead you to a vertical line for the graph of x equal to 2. And the same way, but flipped, we will get the same, we will get the graph for y equal to 2. So in this one, x can be anything and y is always 2. So you can pick random values you wish. So 0 and negative 5, let's say. So 0, 2 would actually be here. And then negative 5, 2 would be here. You could recognize this is that y equals stuff. That means I'm in this part of the HOIVUX acronym. It's a horizontal line at the height of 2. So we end up with this graph like this. Okay, you're still going to plot 2 points somehow along the way. They don't necessarily have to be the same points, just like on the other ones. Any questions on those? Horizontal and vertical are a little different. Okay, a couple of very important features about graphs are intercepts. X-intercept and Y-intercept specifically. So the X-intercept is the location where an equation crosses the x-axis. And this is the specific location when y equals 0. And then your Y-intercept is the location where an equation crosses the y-axis. And that's specifically the location when x is equal to 0. So when I think about intercepts, I think about it as those last 2 pieces that are in parentheses. If I'm trying to find x-intercepts, I let y equal 0. If I'm trying to find y-intercepts, I let x equal 0. I always take the other variable and make it 0 to find it. That's how I think about it. So we can actually look at a graph and determine what the x and the y-intercepts are. So as we did back in the first unit, this is my x-axis, of course, and my y-axis. So on my x-axis, where am I crossing the x-axis? At 2. Now, it's really important to remember that our intercepts are points, and points are ordered pairs. Okay, so we can't just say x is 2. Choose a number. I need an ordered pair. So 2, 0. Right. So x is 2, y is 0. And then what is my y-intercept? Yeah, it's down here at negative 2. So that's the y value for my ordered pair. What's the x value? 0. Okay, so if you forget to write it in ordered pair form, I guarantee my answer key takes off points because it has to be written as a point in order for it to be an intercept, because intercepts are points. The reality is that most people, when they mess this up, say something like y equals negative 2. And what is this? It's not a point. It's a line, right? That's a line. So you can't say the x-intercept is or the y-intercept is and write an equation of a line, which is the tendency when people forget to write it as a point. So be very careful about this. We don't want it written in line form. We can do this with, I guess I didn't get that cleared off from last time. We can do this with equations as well. So we don't have the graph given to us, but in a very real sense from what we were talking about over here, I can find the x-intercept by plugging 0 in for y, and correspondingly the y-intercept by plugging 0 in for x. So as we're working with this one right here, It lists x first, so I'll find my x-intercept first. So my x-intercept is when y is equal to 0. So I evaluate this with 0 for y. So this gives me 3x equals 12. What's x? 4. Now x is equal to 4 solves the equation, but the x-intercept is 4, 0. Right? X is 4, y is 0.
So when you're trying to find the x-intercept, you plug in 0 for the y?
Mhm. Yes, you do. And then if we're finding the y-intercept, what are we going to do?
Put 0 as x.
Yeah, we're going to put 0 in for x. So I have 3 times 0 minus 2y equals to 12. So this is negative 2y equals 12. What's y? Negative 6. So my y-intercept is 0, negative 6. Always as an ordered pair. Okay, any questions on that? All right, if we have this information on this, we could actually graph this line. We're going to do it here in just a second. But these are 2 points, right? And what do we need in order to graph a line? 2 points. So if we have those 2 points, we can actually put them on the graph. We could connect them with a line. So on the next one, they actually give us information. I've already done it last semester, sorry. They give us information in verbal form describing what the x and the y-intercept are, and they ask us to graph it. They didn't write it in point slope form because they wrote it in a verbal format. But they say that we're going to graph the line whose x-intercept is negative 3 and y-intercept is negative 2. So you're going to sketch the graph. X is negative 3, so that means it crosses the x-axis at negative 3. The y-intercept is negative 2, so it crosses the y-axis at negative 2. And all it takes is 2 points to create a line, which we now have. So we'll connect them. Like so. What do you think? That's it for this section.